So what is mean by flip-flop? First tell me.
It is a sequential device which can store only one bit.
It can store one bit, and yes, it is a sequential circuit. It is also a clock circuit. That means it requires a clock. Flip-flop requires clock. Latches that don't require clocks. But we are now discussing about flip-flops. That means it will have one of the input that is a clock. And depending on the rising edge or the falling edge. Okay, so as per the design, so depending on this, in our case, we are going to consider rising edge. So depending on rising edge of the clock signal, it will change its state. Okay, so that is a clock. That is a flip-flop circuit. Now, what are the different types of flip-flop?
T flip-flop, D flip-flop, SR flip-flop, and JK flip-flop.
Yes, D flip flop, T flip flop, then JK flip flop, SR flip flop. These are some of the types of flip flops. So let us discuss about these flip flops and let us perform a practical related with that. Okay, so we are going to write a VHDL code for all these uh, flip flops, and then we are going to simulate these VHDL code for each of this flip flop. Okay, so let us first of all consider D flip flop. Okay, so this is a widely used flip flop. Can anybody tell me what is the D flip flop? What is the truth table for D flip flop?
Ma'am, D flip-flop means delay flip-flop, which whatever we give the input to that flip-flop, it gives the same output. Means if we given to that D flip-flop is 0, then we got 0, and if we given to that flip-flop is 1, then we got 1.
Yes, it will have it will give us the same output but just a delayed output. Okay, so depending on the clock signal, it will give us that output. So at the rising edge of the clock, whatever is the value present at the input, that will be available at the output. Okay, so that is a D flip flop. So we are going to write a VHDL code for this flip flop, and then uh, we will simulate this. Okay, sharing my screen. So what are, how many inputs are there for day flip flop? Avinash?
D and clock.
There are
Two.
two inputs. One is the clock input and another one that is a D input. Okay, so yes, these are the two inputs. So let us create a new project. So let us give the name to this as a flip underscore flop is the name that is given. Okay, we are keeping top level source type as a HDL. So next, these are the settings for this project. That is, we have selected Spartan 3E family, then device XE3S500E, and package that is a VQ100. And we have selected simulator, that is ISIM simulator, and preferred language, that is a VHDL. Okay, so all these settings that we have done for this project, and let us click on next. So you will get the summary of this project and then click on finish. So here in a hierarchy, you can see this project. So right click on this project name and right click on new source. Okay. We are going to write a VHDL model. So click on VHDL model and give a name to this flipper. So let us give the name to this as a DFF. So this is a D flip flop that we are going to first simulate. So let us have a name to this flip-flop file name, that is a DFF. Okay, so click on next. Now let us have the inputs, that is a D, which is a one input, and another input, that is a clock. And let us say Q is the output. Okay, so all are the bits. So in this way we have selected a uh, port names in this entity, that is a DFS. Okay, so by default, whatever name that is given to the source, that is considered as an entity name, and architecture name, that is a behavior. If you want to change this, you can change it. So let us keep it as it is. So that will not make much difference. Okay, so click on next, click on finish. Okay. So here you will get the skeleton for this VHDL code. So here it is a library declaration part. So library IEEE, that is declared, and the package is added to that library, that is a use IEEE.std underscore logic underscore 1164 dot all. That package is added, and then entity declaration part is. So in entity, we have declared port, that is a D, which is a in, and by default it is taken as a std underscore logic. Okay. So whenever you are declaring any port in a VHDL in a Xilinx, so it will take a type, that is a std underscore logic. Okay. So that is the recommended by IEEE library. So it will take this type. So then clock, that is a in a port, and it is a again std underscore logic type, and q, that is output port, which is a again std underscore type. Okay. Then end of this entity, and then after that there we have to write a architecture. Okay. So architecture of this D flip flop is, let us say, with the begin. Okay, start with begin. Now what will be there in this architecture? How to write this architecture? Okay, you tell me what will be the code for this. Okay, Megha, what will be code? How to write a code for this D flip flop? So here what we want to Q, that means output should have the value whatever is assigned at D when there is a change in a clock signal. Okay, so that means we need to execute certain sequential statements. Okay, and that is why we need to have a process to process. Okay, and then with respect to clock, this changes should happen. Okay, so the sensitivity parameter for this is a clock. Okay. Then beginning of the process, and then what we want, if clock signal is high, then only q should be assigned to the value of d. Okay, so here we need to have this if statement, that if clock is equal to 1, and there is a clock event, that means it is changing from low signal to high signal. So clock event, then q is assigned with the value of d. End of this if statement, end of process, and end of this architecture. Okay, so that is the end of behavior. Okay. So this is a very simple code for this D flip flop. So let us save this. Okay, and then let us synthesize this code. So first of all, we will check syntax. Okay, so there are so many errors. Okay, can anybody tell me what is the first error in this code?
Ma'am, spelling clock.
काय चुकलं?
CLK आहे ते तर clock.
Yes, yes, yes. Okay, so we need to have this as a CL. Okay, again here it should be CLK. Here it should be.
Ma'am, capital.
ओके, ठीक आहे, मी आता असंच ठेवते आणि त्याच्यानंतर बघूयात की आपण कॅपिटल नाही ठेवलं तर काय होणार. ठीक आहे. ओके, सो लेट अस
Okay, ma'am.
save this. ठीक आहे, and then I will once again check the syntax. Okay, so you can see here this process of checking syntax is completed successfully. That means though we have written this clock in a lower case, it is not making a difference. Okay, so there is no any difference whether we are writing it in a uppercase or lowercase. Already we have said that VHDL is a case insensitive. म्हणजे तुम्ही कुठल्याही केसमध्ये घ्या. म्हणजे मी जरी आता इथे म्हटलं असं केलं की क्लॉक मी मधलं सी फक्त कॅपिटल केलं, एल के स्मॉल ठेवला, काही फरक पडणार नाही. मी कम्प्लीट सीएल के स्मॉल लोअर केस मध्ये ठेवलं तरी काही फरक पडणार नाही. मी ते आज पर मी इथे जे मेन्शन केलंय सीएल के इन अप्पर केस मध्ये, तर तसं केलं काही फरक पडणार. म्हणजे आता तुम्ही आता सुद्धा बघू शकता मी इथलं फक्त सीएल के मधला सी कॅपिटल केलाय, बाकीचे इथे स्मॉल ठेवलेत आणि ऍक्च्युली इथं डिक्लेअर करताना मी कॅपिटल केलाय. तरी पण तुम्ही जर बघितलं ओके, तरीही माझं सिंटॅक्स हे सक्सेसफुली कम्प्लीट होतं. ओके, म्हणजे चेक सिंटॅक्स प्रोसेस जी आहे ती सक्सेसफुली कम्प्लीट होते. म्हणजेच परत एकदा मी मेन्शन केलं, तुम्ही कुठल्याही केसमध्ये लिहिलं काहीही फरक पडणार नाही. पण हे फक्त VHDL मध्ये, व्हेरिलॉग मध्ये नाहीये तसं. व्हेरिलॉग मध्ये जर जेव्हा तुम्ही कोड लिहिता तेव्हा तुम्हाला प्रॉपर अटेन्शन पे करावं लागतं की तुम्ही कुठल्या केसमध्ये लिहिताय आणि त्याच्याप्रमाणे तुम्हाला करायला लागतं. पण इथे तसा काहीच संबंध नाहीये, तुम्ही कुठल्याही केसमध्ये लिहू शकता. ओके, फक्त ते जे काही लेटर्स आहेत, अल्फाबेट्स तुम्ही यूज करताय ते त्याच सिक्वेन्स मध्ये यायला पाहिजे. ओके, म्हणजे मगाशी मी CLK च्या ऐवजी CLOCK वापरलं. ओके, देन इट इज गिव्हिंग एरर, बट इफ इट इज इन एनी ऑफ द केस इट विल नॉट गिव्ह एरर. ओके, so is this clear to you all?
Yes, ma'am.
Okay, so now let us view RTL schematic. Okay, so this is a RTL schematic where this one is the input for the clock signal and this is D input. Okay, and there is a one output that is the clock. Okay, and if you click on this, you will get this clock. Again, you can click on this. Okay, so this is the RTL schematic for this. D flip flop. Okay, now let us write a test bench for this. So let us right click on the test entity or program. and write a test bench. I'm giving the name to this test bench as a DFF underscore TB. Okay. Don't forget to click on the here module, which source type you want to select. So I'm going to write a VHDL test bench. So here I'm clicking on VHDL test bench and then click on next. Okay. Associate this source with the earlier source, that is a DFF, and then click on here. You will get the summary and then click on finish. Just close this RTL schematic. So here what you will find a new VHDL code which will be related to the earlier VHDL code that we have written for D flip-flop. Okay. So here associated with that, this is the automatically generated code. So library declaration part will be there as per the earlier whatever we have done. And then in a entity, there will no any port declaration part will be there. Okay, so just entity declaration for this VHDL code. So that will be there. And then in the architecture, this component DFF will be declared. Okay, so this, as we are associating our test bench with this DFF VHDL code. Okay, so depending on that code, here a test bench will get generated. Okay, so whatever we have declared in this code. Okay, so these ports that will be declared as a ports of these components. Okay, so D, C, L, K, and Q. These are the ports, and then after that, here these are the input pins for this component. Okay, so whatever are the nets in that component, that will be considered now as a signal. And then here um, this signal assignment, that is a D, is considered as a signal which is of the std underscore logic, and initial value that will be 0 for it. Then clock, that will be again a having initial value as a 0, and then clock signal Q. And then as here we require a clock signal, so we are going to assign a constant value for the clock period. Okay, so constant clock period, and which will have the time, that is of 10 nanosecond. Okay, so clock period is of type. Okay, time. So here it will have certain value, so that is a 10 nanosecond, and then we are beginning with the actual architecture. Okay, so here for the architecture, we have to instantiate the unit under test. So unit under state test, that will be uh, map ports of that unit under test, that will be mapped with the component ports, and here so this port mapping is done. Okay, so D is mapped with D, then clock, that is with the clock, Q is with a Q. Okay, and then after that there is a clock process. So this clock process, that will define what is the on time and off time of the clock signal. So clock will be having 0 value for clock period divided by 2 times. That means for 5 nanosecond, and it will have 1 value for clock period divided by 2. So end of this process, and after that we need to write a similar process. Okay. So let us wait for 10 nanosecond first, and then so let us first say D is having the value that is equal to 1. I will keep this as it is. Okay, and then let us wait for okay. I will make this as a 12 nanosecond so that you will get the idea about when to change. Let us make next thing, that is okay. So this is a Wait for 10 clock cycles. Okay, and then wait, and end of the process, end of the architecture. Okay. Now, is this code is correct? काहीतरी कोड लिहिला. So tell me. Shall I save this so that you will get idea? बरोबर आहे का कोड लिहिलेला? सिम्युलेट करूयात. Okay, let us check syntax. So there is error. The behavioral check syntax has been failed. Why? What is the error? Type std underscore logic does not match with a string literal. Okay, we at line 85. Then at line 87, again the same error. Again at line 89, the same error is there. And then as we have ignored earlier errors, so that is why the next error is. Okay. So tell me what is the error? मी पर्पजली याच्यामध्ये काहीतरी रॉंग केलं. तुम्ही मला सांगायचं की ते काय आहे. सो करेक्ट एरर्स. Okay, so in between that, let me check how many are sincerely attending these sessions. Okay, and I will show it to you also. Just see. Okay. ते कोण आहे? हर्षल कदम. फक्त इथे जॉईन झालं, पुढे नाही आहे. स्नेहल पुराणिक इथे जॉईन झाले, पुढे नाही आहे पुढच्या सगळ्याच टाइम स्लॉट मध्ये. Just check this. ओके. सांगा मला एरर काय आहे? श्वेता, वैष्णवी,
Yes, ma'am.
what is the error? ओके, मी परत एकदा वाचते. इथे एरर काय आहे आपल्याला? टाइप std underscore logic does not match with a string literal. We have assigned certain values, that is the literal value. Okay, so string values that we have assigned, and we have mentioned these values in a double quote. पण मी तुम्हाला जर आठवत असेल तर मी प्रत्येक वेळेला सांगते की जेव्हा सिंगल बिट असेल तेव्हा आपण काय करतो? सिंगल कोट मध्ये वापरतो. आणि जर वेक्टर असेल म्हणजेच बस साठीची जी व्हॅल्यू आपण असाइन करणार आहे ती आपण डबल कोट मध्ये लिहितो. ओके, इथे आपण ही व्हॅल्यू मेन्शन करणं गरजेचं आहे सिंगल कोट मध्ये. Again, this value should be in a single quote. Let us save this one second. Okay, and then check the syntax. Okay, now you can see the process behavioral check syntax that is completed successfully. Okay, so let us now simulate this model. So here initially we have assigned the value for a D as well as clock, that is a 0, but we have not initialized any value for Q, and that is why it is showing uninitialized value. Okay, then here we have assigned a clock that is equal or that after 5 nanosecond clock will go high, but at that time as a D is equal to 0, so clock will be equal to sorry, output will be equal to 0. Now in the next okay, after that we are making, after 10 nanosecond we are making D is equal to 1. Okay, but here as the clock signal is 0, so that is why Q that will be equal to 0. But whenever here there is a clock event and clock is going from low to high, that time output will change from here and it will go to the high. म्हणजे जी काही D ची व्हॅल्यू असेल ती तुम्हाला इथे मिळणार आहे. कधी मिळणार आहे? जेव्हा क्लॉक हा low to high जातोय. Okay, so here you can see there is a change in the output. Now this will remain till there is a next positive going clock signal will appear. Okay, so ज्यावेळेस तुमचं जर डी ची व्हॅल्यू चेंज झाली असेल आणि जर क्लॉकची क्लॉक जर हाय टू लो टू हाय जात असेल तर तुमचा आउटपुट परत काय होणार आहे? चेंज होणार आहे. So here you can see after 12 nanosecond we have changed the value of D and we made it to 0. Okay, but still as there is no any positive going edge of a clock signal, so output will remain as a 1. But the instance at clock goes from low to high, okay, and it remains as a high, output will change to 0. Okay, then here after 15 nanosecond again once again we are changing value of D and we are making it as a 1. Okay, so here you can see the clock signal is high, but there is no clock event is happening. Okay, so that means there is no any change from low signal to high signal. So output will not change its value, but it will remain as it is till there is a next positive going edge will appear. Okay, so here it happens, and then here only output will change from low to high. Okay, so this is a D flip flop. ओके, इथे काय होतं की ज्या ज्या वेळेला क्लॉक तुमचं पॉझिटिव्ह असणार आहे आणि क्लॉक पॉझिटिव्ह गोइंग एज असेल क्लॉक सिग्नलची आणि क्लॉक हाय जाणार आहे, त्या त्या वेळेला जी काही डी ची व्हॅल्यू असेल ती तुमच्या आउटपुटला मिळणार आहे. ओके, सो दिस इज अबाउट द डी फ्लिप फ्लॉप. कुणाला काही डाऊट आहे याच्याबद्दल? इज देअर एनी डाऊट?
No, ma'am.
Okay, so this is a very simple VHDL code for a flip flop. Okay, so next if you don't have any doubt, let us proceed for the next flip flop. Okay, so I'll stop this simulation. कुणाला काही डाऊट नाहीये ना? सगळ्यांच्या लक्षात आलंय? इथे व्हेरिएशन्स कसे होतात हे लक्षात येत आहे सगळ्यांच्या? तुम्ही झूम करून बघू शकता तुमच्या मोबाईल मध्ये. तुमचं मोबाईल स्क्रीन जी काही आहे ती तुम्ही झूम करा आणि तुमच्या लक्षात येईल की प्रत्येक ठिकाणी म्हणजे इथे जेव्हा क्लॉक सिग्नल हाय जातो तेव्हा आउटपुट चेंज केलं, इकडे त्याच्यानंतर जेव्हा क्लॉक सिग्नल हाय गेलं तेव्हा आउटपुट चेंज झालं आणि इथे चेंज झालं. ओके, जरी इन बिटवीन चेंज झाला असेल तरी त्या इन्स्टन्सला क्लॉक हाय जात नाहीये जोपर्यंत, म्हणजे लो टू हाय ट्रान्झिशन जोपर्यंत होत नाहीये तोपर्यंत आउटपुट हे चेंज होणार नाहीये. ओके, सो दिस इज अ डी फ्लिप फ्लॉप. So I'll stop this and now let us move towards the another flip flop. Okay, so let us now discuss about T flip flop. Okay, what is T flip flop? T flip flop म्हणजे काय? Yes, it is a toggle flip flop.
Toggle
Okay?
flip flop, ma'am.
Yes, okay. So how it works?
Ma'am, when we give it to 0, then it gives output as a 1, and when we give it to 1, it gives output as 0. So that it is called a toggle flip flop.
Yes, okay. So in a toggle flip flop, with each positive edge of the clock, output changes okay, it toggles. Okay, so that means if for t is equal to 0, if suppose q is equal to, that q will become as a 1, and for um, if t is equal to sorry, actually whatever is the output in state in a earlier state, okay, so that will change. That means for t is equal to 0, if the previous state is 0, then it will remain as a 0, and for uh, t is equal to 1, if it is 0, then it will change as a 1, and if the previous state is a 0, then it will make as a, or change it as a 1, and if it is a 1, then it will be as a 0. ओके, म्हणजे जर तुमचा टी सिग्नल हा हाय असेल तरच टॉगल होणार आहे. जर टी 0 असेल तर जे काही आहे आधीच्या स्टेटमध्ये तसंच आउटपुट राहणार आहे. ओके, आणि हे कधी ट्रान्झिशन होणार आहे, जेव्हा क्लॉक हा हाय टू लो चेंज होईल, लो टू हाय चेंज होणार आहे, म्हणजे पॉझिटिव्ह गोईंग एज असतात. Okay, so now let us have this another project in this another source. Okay, not a project, another source in the same project. Okay, so we will have VHDL model. Okay, and we will give the name to this as a TF. That is a toggle flip flop. Then next, so here input is a T, then clock, and next is the output, that is a Q. If you want one more output, you can go for checking of Q bar also. Okay, so we can say this as a, we will check this also Q bar. Okay, this is again out. So these are the two input ports and two output ports for this flip flop. We are giving the architecture name as a behavior. Okay, so click on next. Here you will find the summary and click on finish. So once again, you will find here after entering the names or declaring the port names. So you will get the skeleton for this VHDL code. So this is the library declaration part, then entity declaration part, that will be there. Okay, so whatever ports you have assigned earlier, so that will be present in the port declaration part. So T and CLK, these are the input ports, and Q and Q bar, these are the output ports. Okay, so let us write now architectural code. Okay, so here uh, we will have one temporary signal in this. Okay, so this is a signal temp, which is std underscore lot. Okay, and then we will write. So here what we are doing, we are considering one temporary signal that we are going to use in this architecture. Okay, so now we will have the process. So it is going to change with a clock signal. So PLK, yes, okay, and then begin of this process. If CLK is equal to 1 and clock event, then if t equal to 0, then ten is assigned value, that is 10. Okay, so that means we are assigning or we are having a temporary signals. Okay, so if t is equal to 0, so whatever is the value of this temp signal, that will remain as it is. Okay, so that will remain as it is. And then else if t equal to 1, then 10 is assigned with the value that is not 10. And if again end if, because we have used the two end statements, so end if and then end of the process. Okay, instead of using this temp signal, you can directly go for q, but we have used this. Okay, so then q, that is equal to temp, and we have used one more signal, output signal, that is the q bar. So q bar, that is equal to not of 10. So you can have it as a not of q. Okay, so here end of this behavior. So this is the VHDL code for T flip flop. Now we want to simulate this TFF. Okay, so click on TFF. Now we don't want this, though we have written two different VHDL codes here. So we want to simulate this. So here we are going to click on this, and then we are going to check syntax. Okay, so here this check syntax, that part is completed successfully. Okay, so now let us write a test bench code for this. Okay, so right click on this, click on new source, click on VHDL test bench, and then give the name to the name this test bench. So this is a TFF test bench. Next. Okay. Now here you want to associate this source with a TFF. Okay, so click on TFF. तुम्हाला काय करायचंय, आता जो तुम्ही सोर्स लिहिताय म्हणजे ते जे टेस्ट बेंच लिहिताय तुम्हाला कुठल्या VHDL कोड बरोबर असोसिएट करायचंय, तर जो काही तुम्ही टॉगल फ्लिप फ्लॉप साठी लिहिला होता त्याच्यासाठी. त्यामुळे काय करायचं, याच्यावरती TFF वरती क्लिक करायचं. अदरवाईज काय होणार आहे, तुम्ही जर DFF वरती क्लिक केलं तर तो जो कंपोनंट आहे तो तुमच्या टेस्ट बेंच मध्ये येईल. ओके, पण तुम्हाला टॉगल फ्लिप फ्लॉपचा कोड साठीचा जो कंपोनंट आहे तो हवाय, त्यामुळे इथे असोसिएट करताना तुम्ही TFF ला असोसिएट करायचं अँड देन क्लिक ऑन नेक्स्ट. ओके, आता इथे आपण काय केलं, एकाच प्रोजेक्ट मध्ये आपण वेगळे वेगळे VHDL कोड लिहितोय म्हणून हे असं आहे. तुम्ही वेगळे पण प्रोजेक्ट करू शकता, पण ज्यावेळेस तुम्हाला एकाच प्रोजेक्ट मध्ये हे सगळं यूज करायचं असेल तर तिथे तुम्हाला हे इझी जातं की तुम्ही एकाच ठिकाणी सगळं केलं. ओके, म्हणजे सगळे सोर्स कोड लिहिले. So that we are doing here. So click on finish, and here you will find the test bench code. Okay, so here this is a test bench code. TFF that is instantiated here, that component. So it is there. So like earlier one, it is there. So initially we have kept t value is equal to 0, clock is equal to 0, and then q and q bar that we have not assigned any value, initial value, but it is the signal which is of the type std underscore logic. Okay, clock period that we are keeping it as a 10 nanosecond, you can change this. Then there is a port mapping of all these ports, and after that there is a clock process. Okay, after clock process, now we are going to write a stimulus. Okay, so we will keep this reset condition for 10 nanoseconds, and after that we are making t equal to 1. Let us wait for next 13 nanoseconds. Let us make t equal to 0. Okay, so these are the stimulus that we have given. So that is a t. For first 13 nanosecond, we are keeping it for the 1 value. Then after that, we are keeping it 0 nanosecond, 0 value, then again 1 and 0. Okay, so these are the changes that we have done. Okay, and then let us take this. Then we are going for the simulation. ओके, आता परत आपल्याला काय करायचंय, इथला TFF चा कोड आपल्याला सिम्युलेट करायचा आहे. सो क्लिक ऑन TFF टेस्ट बेंच. चेक फॉर द बिहेवियरल चेक सिंटॅक्स. It is completed successfully, so you can simulate this behavioral model. So what you can see here, there is a error in the output. Actually, what should happen here? काय व्हायला हवं होतं, आपण टीच्या व्हॅल्यू चेंज करतोय, 1 करतोय, नंतर थोड्या वेळानंतर 0 करतोय, परत 1 करतोय. सो त्याच्याप्रमाणे आपलं ऍक्च्युली आउटपुट चेंज व्हायला पाहिजे होतं, बट दॅट इज नॉट हॅपनिंग हियर इन दिस केस. सो कॅन एनीबडी टेल मी व्हॉट इज द एरर इन द कोड? ऍक्च्युली सिंटॅक्स बरोबर आहे, पण आपलं लॉजिक मध्ये काहीतरी प्रॉब्लेम झाला. सो व्हॉट इज दॅट? Problem is in this code. So tell me what is the problem? Okay. In the next session, once again we will simulate this, and we are going to simulate for the SR flip flop and JK flip flop. Okay. So पुढच्या सेशन मध्ये मला सांगायचं की इथे प्रॉब्लेम काय होता, काय चुकलं. Okay. So for today we will stop here. Okay, but this is your homework that you need to debug this code. Okay, and tell me what is the error in this code. Okay, काय डाऊट आहे?
ओके मॅम. नो मॅम.
ओके, आज आपण इथेच थांबूयात. नेक्स्ट सेशन मध्ये आपण परत फ्लिपफ्लॉप, उरलेले जे फ्लिपफ्लॉप ते आणि याची मधली जी एरर आहे ते आपण करेक्ट करणार आहे. ठीक आहे. सो फॉर टुडे वी विल स्टॉप हियर.